Great, so what we're going to talk about now is really critically think about what we've learned from 1D FEM, think about it, reflect on it, and then say, if we really understood this very well, we would be able to really have education, good guesses of what would happen in 2D. And to such an extent, we should be able to extrapolate quite efficiently from 1D to 2D. And if we struggle to extrapolate from 1D to 2D, it might show that we don't understand 100% what we've learned in the 1D case. So this is why I like to use this 1D to 2D kind of extension. It really allows and forces us to really critically reflect what we've learned sort of from the 1D case towards the 2D case. Okay, so let's see. So what I'm going to do is I'm just going to work through the 1D stuff, then I'm going to stop the video, and then we're going to start reflecting on the sections that I'm writing down on the 1D towards 2D. Okay, so let's start off with 1D. So we can start off quite to the left. Okay, so that's the first thing is we have some displacement field. Okay, so that's essentially one of the aspects that we have, a displacement field. What do we know about the displacement field in 1D? Well, in 1D, there's only one displacement field, a U field, which is a variable, it's a function of only one variable, x. And it's got associated unknowns, q's, okay, that it might have. So essentially we wrote it down as this n1 q1 plus n2 q2 plus n3 q3. So that's what we if we just want to visualize this quickly, we have two worlds in which we can visualize this, the psi world, or the other world might be, I'm going to draw it so it's in a different scale, might be the x world, and it might have x1, x2, x3 variables there. We know that from psi, this is from 0, psi is 0 here, so from there the psi variable goes on. So that's sort of the origin of that axis. The x-axis could be anywhere, like the x-axis could actually start technically here. So let me just wipe that off so that I can just, instead of just reflecting that it's a axis, but make sure that it's got some origin. So this x could start from here somewhere. The psi we know will start from there. It's -1, +1. That's what we know about psi. Yeah. There's some unknown displacements associated with these things as well. So this could maybe a q1, a q2, and a q3. This local kind of unknowns that we might have. Also, instead of just the local unknowns, we might have the, I think we call them the bars. We might also have then the global unknowns, q1, q2, and a q3, for instance. So that's the kind of stuff that we've learned. Okay, in 1D. So that's the displacement field. We also have something else which has, which is essentially taking this displacement field. Well, let me maybe let's talk about the isoparametric. So this is the geometrical field, geometry, isoparametric. Yeah. And so the isoparametric, we're writing x, okay, as a function of psi, and its x coordinates. So let me write these x coordinates maybe, so I can just differentiate from x bar vector. So I'm going to call these bars as well. So those are the coordinates, so that we just differentiate from this x. And so let's call it n1 x1 bar, n2 x2 bar, n3 x3 bar. Okay, so that's essentially what we have there. Beautiful. This is our geometrical description of the problem. Okay, now it's a function of psi. We have essentially, the next thing was our strain fields. Okay, and I'm not going to write down the weighting functions, but the weighting functions had the same shape and same form as this U field, so that's something that's going to be implied. Okay, but let's focus on the solid mechanics side of things as well, in terms of just the walking through the steps. So we have displacement, we've got some geometry, we've got some strain, stress. Once we're there, then we can stop and say, let's think and reflect. What do we expect displacement to look like in 2D? What do you expect this geometry to look like in 2D? What do you expect the strain to look like in 2D? What do we expect the stress to look like in 2D? Okay, so strain, essentially what is that? That is the strain field that we had was equal to BQ. Yeah, remember this? So that was that. And the BQ was essentially d psi. Oh, okay. I'm gonna write it. Maybe I'll write it as the variable, not as the. So d psi. I hope that's not. Oh, that's hectically smudged. My word, this is terrible. These cookies are very nice in terms of the way they write, but yeah, they make a mess. It's like this cloud of dust almost. Okay, so let's call it psi dx. That's the spatial variable, and then essentially what we have is we have the derivatives of the n with respect to psi. Okay, so this is this n vector, if you want to think of it like bring this n1, n2, n3 as a vector, and then we can multiply it with the q vector, for instance. Okay, and this is with respect to psi, so not xi. So maybe just make it this psi variable. I'm writing psi now out because of the Python, but psi. Okay, so that's what we have there. When we get to the stress field, we essentially have a stress. This is the Voigt notation again. I'm just going to remind you that you remember this is Voigt notation, although it's 1D. So this is just when we get here, just to help you think about that. Then we essentially have material BQ. Okay, so material constitutive relation here times the BQ here. So essentially that would be E psi x n psi q. Okay, so that's essentially what we have there. Like this vectors with vectors here. In this case, the E is the scalar. So this is the 1D case. If we think about this and we walk through this, that we have. And just as a reminder, these fields are, should not be lazy, but I should also just remind you that they are a function of psi, and this is also a function of psi. Okay, that's clear. So that's a function. So this lives in this psi world. This B, it's also a function of the x's because of the partial psi partial x. So I'm going to put the x's in the x bar. Also plays a role. This x bar also plays a role via the isoparametric formulation. Okay, so I'm going to make it clear that it's clear to that. Okay, so that's what we have, and this is then the description of the displacement field geometry, strain and stress over sort of an element, and then we've learned now how to string them together. So let's just first focus on that. What I'm going to do is I'm going to stop the video, and then we're going to start reflecting on these various 2D kind of